What is control flow? The control flow of a language specify the order in which computations are performed. Now, this quote comes straight out of the book, The C Programming Language, 2nd edition, by Brian W. Kernighan and Dennis M. Ritchie, in Chapter 3, titled Control Flow. So what constitutes control flow, or what are the statements that make up the control flow of C? First off, statements, the fact that you can create statements, right? So we'll talk about statements, blocks, okay? Branching, which includes if else, else if, switch, looping, which includes the for statement, the while statement, and the do while statement. And then two keywords, break and continue, which allow you to then fine tune the exiting or the continuing of these different branching and looping statements. Okay, so let's start with statements and blocks. All right, I'm going to create my project. So dir, and I think let me see here, make dir control flow, and then change directory into control flow. Okay, and then start up Visual Studio Code. Okay, now I'm going to just create a main.c source file and shut down my welcome here. And you should see, the text should be big enough for you to see. Okay, so I'm going to start off with a comment. So demonstrate. Let me get my fingers right. Demonstrate control flow statements. Okay, and I'm going to include standard IO.h, and I'm going to flesh out the main function and return 0. Okay, so we're starting with statements and blocks, and statements are a key part of control flow in C. All right, so let me just write a comment here. So statements and blocks, statements and blocks. Okay, most people find the block thing kind of interesting, right? They don't usually think of the ability to do what I'm going to show you. Okay, now an expression becomes a statement when it's terminated by a semicolon, right? So I'm just going to add that comment here. An expression becomes a statement when terminated when it is terminated when it's terminated by a semicolon. So let's take a look at that. So here we have an expression, int I equals 0, and that makes it a statement right there, that semicolon. Just as if a print statement. So if we had a printf, and then I equals, and then %d, right, and then /n, comma I, right, and we terminate that, that's a statement. Okay, so it's a pretty easy concept there. Now the next thing are, if you use braces, you can create blocks of related statements, or these are also called compound statements, right? So braces group declaration and statements into compound statements. Okay, in other words, these is also known as blocks. So let's see this in action, right? So you just open in the middle of a main even, right? Or any function. Okay. So we just have open and close brace, and then I can redeclare I. Int I equals 3. Now at this point we have to talk about a concept called scoping. So here I've declared in the outer scope, in the scope of this main function, I've declared I, and I set it to 0. Here I'm redeclaring I, so this I is visible. This I up here is also visible, but this one takes precedent, right? Because I'm just redeclaring right over top of that. All right. So int I equals 3, and then if I have a print statement here, right? So I'm going to say printf, and I'll say inner scope I, equals, and then %d, /n, and then comma I, and then of course, terminate, make it a statement. So now let's just, and actually I'll add one more statement. I'll add a printf to kind of printf again. I'm just going to do this. Printf, copy this one, and then come down here and v. Now I'll say outer scope I. Okay, equals. And I'll change that to equals. All right. So now let's run this, and we'll see that we'll see I declared in the outer scope, and then we'll redeclare it in this block here, right? A compound statement, and then we'll print I again. So we'll see that the value changes. Okay. So Control Save, and let's run it. So I'm in Control Flow, CLS. GCC, let's compile it. GCC main.c, and then run it. /a out. All right, so he will have the I, right? That's the outer scope I right there, equals 0. Inner scope I equals 3, and then outer scope I equals 0. All right. Now, let's move on to branching statements. All right, I'll return to the code, and I will print out just a divider, right? So we can see things on the console better when we move between these different, when the code runs. So printf, and I'll do, that looks fine. Branching statements. And then blah, 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 blah. That looks close enough. /n, and then semicolon. I have to remind myself to do a semicolon because I'm teaching a course in Python. Okay. At this point now, we'll start off with the if-else. Okay, so the if-else is used, to branch to a different path, right? So essentially the if-else, is used to branch to a different path of execution based on the evaluation of a conditional expression. So used to branch to a different path of execution based on the based on a conditional expression. Okay, so let's see that in action. So here I'm just going to say if I less than 5. So now we're talking about this outer scope I, right? So this inner scope I in this block is only local to this block. Okay, so if I is less than 5, and then I always use block statements in my, you could say if you only had one line of code or one statement, right? After that if, you wouldn't need the braces, but I always put the braces, even if I only have one line of code. So printf And here I'm just going to say, so if I is less than 5, I'm just going to say %d is less than 5. Okay, /n, and then quote, and then comma I. Okay, so there's my printf. Now, the else clause in this case, if you don't need an else, it's optional. Okay, but I'm going to put the else clause in here. Okay, so but I will make a comment here. Else clause is optional. And then I'll say printf %d is equal to or greater than 5. And then /n, quote, and then comma I, and then semicolon. Okay, so if we take a look at this, right, I is going to be 0. So if I is less than, then it will print, this statement. This conditional expression, I less than 5, will evaluate to true. If I is less than 5, if it's greater than 5, or it will then print this statement, right? However, there's nothing that's changing the value of I at this point, so this is just going to print I is less than, or it'll print like the value of I. So it'll say 0 is less than 5, right? So let's run this one and see what it outputs, okay? Just to make sure that we got everything running fine so far. CLS, and then compile it and run it. Okay, so as expected, right? Actually, I got this -s, right? So let me go fix that. I'm not sure what that is. Oh, I see. There we go. Is less than 5. I didn't see that when I was typing. All right. Is there any other Are there any other problems here? So, okay. Save. Compile. Clear the screen. Compile it and run it. Okay, that looks better. So here's the first things. I equals 0. Inner scope I equals 3. Outer scope I equals 0. And then we're into the branching statement section. So 0 is less than 5. The code there's really nothing telling the code to go back up and increment, right? So we'll get to the looping statements here in a bit, right? So that's just one, the if else. Now, if you needed multiple, check multiple conditional expressions for multiple branch pathways, then you could use the else if in conjunction with the if else. So let's write that piece of code. All right. So I'm just going to come down here another few lines, and I'm just going to make another comment. Else if. Okay. So this is used for, go back up here. Used for multiple branching options. So let's see this in action. All right, so if we say if, I think what I'll do is I'll just copy this section up here, right? Because I'm just going to extend it a little bit. Control C, and come down here, Control V. So if I is less than 5, that's fine, okay? And then else if, oh, sorry, I should have just left that else there. Else if, I'm going to put a space here, right? I like to put a space in between these. So else if, all right? So if, and then if that condition evaluates to false, then we'll go to the else if, all right? And in this case, this else if is not optional, right? And then we'll put an else clause here, else. Now this else clause belongs to this right here, right? This is else if, and then else. All right. Actually, I think it belongs to this if right here. So we'll see that in a second. So printf. Now, So if, now we need a condition here, right? So I is equal to 10. In other words, if I is equal to 10, then this line will print. So, okay, so that'll be if, get rid of that, E is equal to 10. Right here, 10, right? So if it's less than 5, this will print out. If it's 10, right? And then if it's anything else, right? So then we're going to go printf %d, %d is equal to, oh, I'm just going to say hello world in this case. Hello world. And then I equal to %d, \n, okay, and then comma I, all right, and terminate that with a semicolon. Okay, now let's go ahead and run this. It's just going to print this right here, right? It's just going to print this top. Once we get into the looping statements, we'll use each of these in the looping statements, and we'll see the different effects. So Control C, save, and let's run it. Oops, sorry, wrong terminal. That term. So CLS, GCC main, A out. All right, so 0 is less than 5. So far, everything's running fine. Let's go back to the code. Now, the next branching statement is the switch. Switch, okay. Now, what this does, this is a multi-way decision statement. Okay, so I think novice programmers kind of shy away from the switch, and they'll use lots of these nested if-else. So there are certain situations where the switch is by far the desired, especially when you have a lot of different cases that you're evaluating, right? So we'll see this here in a second. So switch. Now we're going to switch on I in this case. Okay, so then open brace. Okay, closing brace. Now, so for a switch, right, you're evaluating. So switch I. In other words, I is your expression, like your value that you're going to check, right? What is this value? If one way to read the case is case, well, you're going to add cases to this, right? So if I is 1, right? So case 1, then do something. What I'm going to do is I'm going to say if case is 0 first, right? So if case is 0, colon, and I'm just going to fall through because I'm going to mimic like this if I less than 5. Case 1, okay, I'm going to fall through to the next case. So case 0, case 1, case 2, case 3, case 4, right? So that has to be a colon. I apologize. Colon. Now, case 4 here, we're actually going to do something, and I'm going to use a block, right? Because I always do this in my cases as well. So printf %d, %d is less than 5 /n I. Now, once we've executed this case, then we have to use the break keyword. That will then exit out of the case. So this is falling through. When it goes case 0 and you don't have anything there, and you go to the next line, case 1, case 2, case 3, case 4, then it will say, oh, case 4. If it's either of these, boom, Then case 4 executes, right? If it's 0, it will fall through to case 4. If it's 1, it will fall through to case 4. If it's 2, it will fall through to case 4. Break. Okay, so print, D, %D. So in other words, what it's going to say is whatever the value of I is less than 5. Okay, now the next case is case, because like I say, I am mimicking the previous statement, case 10. Then I want to do something else, right? So here I actually have some statements. So printf, right? And I'll just go ahead and copy these two statements here, save a little bit of time. All right, so is less than 10. Is equal to 10. Is equal to 10. All right. Now, the final thing I'm going to add is a default. So what the default is if it's not 0 through 4, if it's not 10, then it's everything else. And then I'm going to add a block, and I'm going to say printf, and I'm going to say hello world, exclamation point, I equals %D, excuse me, /n, comma I, and then semicolon. So there's my switch. All right. Save it. Now let's run this. Okay. Control save. And let's see what the output looks like. So go to the terminal, clear the screen, compile it, and run it. So we have, this is it, right? So because I is 0, this is the I that we're talking about, right? It's always 0. So all those branching statements are always just going to execute there. That conditional expression will always evaluate to 0, right? Now, let's take a look at looping statements. And in the looping statements, I'll use these branching statements and iterate over a range of values so we can see the effects of these branching statements. Let's return to the code. And I'm going to add another printf with some asterisks here, right? So printf. Actually, I'll just go up here and copy this one. I've already got it done. All right, copy that one. Come down here, and right there, I'm going to paste that and say looping statements. Okay. Now the for, I'm going to start with a for statement. The for statement, I'll say for statement. So the for statement really combines, right, counter variable, initialization, conditional expression, and counter variable increment in a convenient syntax, right? So I'm just going to type that here for a comment. Combines counter, variable, initialization. Okay. Counter conditional expression, evaluation, and counter variable increment. Increment or decrement, right? So I'm not going to give you every example of a for statement, but as the course progresses, right, you'll see a for statements used in different contexts. All right, and variable and counter variable increment in a convenient syntax. Okay. Now let's take a look at that. So I'm going to say, I'm going to print right here. So print f, and I'll say slash, I'll say for statement. For statement. And then /n. This is just so we can see which different statement is executing. All right, so now here, we're going to say for. So what I'm going to do is I'm going to step through a few values and then call, and then like paste in one of the branching, like the if else, then the if else if, and then the switch into each of these different looping statements. So for int I, now this I is going to be its own scope, right? So we're overriding I at this point. So int I equals 0, and I'll say I less than 15 in this case. I plus plus, right? So the for statement includes your counter variable declaration, your conditional expression, and the increment. Okay, now we could change the, this is usually the way that you'll see the for statement written to process through an array or something like that, right? So at this point now, I'm just going to scroll up here and I'm going to go to the if else, right? And I'm just going to paste this. So Control C. All right, now I'm going to paste that right here. And I need to clean up the indenting. So if else, let's push that over and let's push this over. All right, there we go. So now for int I equals 0, I less than 15, I plus plus, if I less than 5, print, the value of I is less than 5. Else, is greater than or equal to 5. So we're just going to see this thing run, and it's going to go through 0, 1, 2, 3, up to 14. Okay? Save it, and we're going to run it. Let's run it and see it tear off here. CLS, main.c, and give myself some more room, CLS, and then run it. Okay. So obviously we start off, we got our branching statements, which are boring, and then looping statements. So the for statement, so we start off at I is 0, and it's less than 5. 1 is less than 5. 2 is less than 5. 4 is less than 5. And then 5 is equal to or greater than 5. So now we're in the else, all right? And all the way up to 14, right? So the first part, this condition is true. I is less than 5, so that print statement runs, right? And then when I is equal to or greater than 5, then the second, the else clause kicks in. Okay, so that's how you control branching with the if else. Now, there's another, so for statement, I'm just going to take the S out of there, so the for statement. Okay, and so the next statement is printf. I'm going to say, I'll do the comment here first. I'll say while statement. All right. So you use a while statement when you want to execute a block of code until conditional expression evaluates to false. Well, I'll just say you execute a block of code while, right, which is really while conditional expression is true. And as soon as that conditional expression is false, then you can exit, or you can exit earlier with the break or statement if you needed to. All right. So now the thing about the conditional expression is I'm going to add another line here. The conditional expression may evaluate to false right off the bat, right? Initially. And then which would prevent the while statement from executing at all, right? Ooh. From executing. In other words, there's a chance that you may not the while statement may not execute because the conditional expression might be false, right? So let's go ahead and write that while statement. So while, now in this case, I'm going to set, okay, I'm going to set I equal to 0 just to make sure, right? That I starts off at 0. That's a 1, right? So I equals 0. So now this is the global I, or the I that's at the, you know, scope in main, right? So now I'm going to say while I, right, is less than equal to 10. Less than equal to 10. And so here I'm going to put the switch in. Okay, so let's go up here for the switch. I'm just going to copy the switch. All right, and I'm just going to paste it right in here. All right, so switch. Now I'm going to indent these cases. Okay, and then push this over. All right, like that. So while I is less than equal to 10, then switch on I. So case if it's 0, 1, 2, 3, 4, then this line will execute. If it's 10, then this section of this block of code will execute. All right. If it's anything else, if it's 5 to 9, right, then this block of code will execute. Now, we have to have some way, and there's a couple ways to do this, right? We have to have a way, or we have to remember that we have to increment I. The for statement allowed us to conveniently put the increment, you know, as part of the statement. We can also do the same thing here. We could say plus plus using the postfix operator. All right. Or you often see it down here too, right? But you have to remember, don't put it in the switch. You got to put it into while. So we say I plus plus. That's another place you'll see it. All right. I'll put it there for now. And that way we can see it, this version of it. So save that while statement. And before I execute this, I'm going to add another, I'm going to say printf /n while statement. While statement. All right. And okay. Now I've got that. So let's save it and let's execute it. All right, so clear the screen and then compile it. And clear the screen one more time. Whoops. And then execute it. Okay, so while statement. 0. Oops. You know what? I needed to put a /n here. So let's compile that again and run it. CLS, GCC main, CLS, and a.out. All right, so here's our while statement. So 0 is less than 5. So these are the cases, right? Because this is these cases right here, right? If as soon as I is 0, it starts off at 0 right here. And then I is 1, I is 2, I is 3, I is 4, then this statement's executing. All right, so let's go back to the console. And then as soon as if I is between 5 and 9, then the default case executes. And as soon as I becomes 10, then the case 10 executes, right? Case I equals 10, right there. Now, a note about these, right? So I've got these magic values in here. A lot of times you want to put constants or symbolic constants to represent these values, right? And as the course progresses, we'll see the case statement with symbolic constants, right? But this is essentially how it works. Now, the thing about the while statement is, like I said, there's a chance that this might not evaluate to true, right? It could be false, which would mean that you would not execute this block of code. So in order to, there's a statement that lets you make sure you execute a block of code at least once, and that is the do while. So do while. will let you, I'll say it executes the block of code at least once, right? And then, I'll say this, and then evaluates the conditional expression. Right, so let's go ahead and put print f slash n do while statement slash n. All right, so then semicolon. Now do, so it's very simple, right? So I'm going to reinitialize I equals 0 just to make sure again, right? So do, and then while and I'm going to put the increment down here, plus plus less than 10, just to give you a demonstration on how to do that. So here's the shell. So do this block of code while I plus plus is less than 10. So this conditional expression will evaluate like this. It'll be whatever I is, which is 0, less than 10. That will be true. And then the I will be incremented, right? This is postfix. If I were to put the plus plus I, or the plus plus in front of the I would increment, and then the comparison between it and 10 would take place, right? So this is the postfix increment operator, and that's how it works, right? So the I and the 10 are evaluated against each other. Is I less than 10? Whatever that results in, true or false, and then I is executed. So now I'm going to paste in the else if, all right? So I did the, let me see here. I'll just do this one here. All right, so paste this in. All right, so let's do this, tab. I'm sorry, I pasted in the for loop. Don't want that. Delete. I can go farther up into the food chain. So here is the else if, or else, and the else if. So let me just copy this code here. And come down here to the do while. So now it's going to execute at least once. So V. And I'm going to tab these over. All right. And tab that over. There we go. Lined up. Now, do, if I equal 5, or I less than 5, then print, the value of I is less than 5. If I equals 10, then print 10. If it's anything between I and 5, right, then it will print out the else clause down here. So I'm going to go to 15 on this one so we can see. No, actually 10's fine. 10's fine. All right, so this is the last one here, and then we're done with this video. So let's go ahead and execute this. Okay, so clear the screen, compile it, and clear the screen one more time, and then run it. Okay, so here's the do while. 0 is less than 5, 0 is less than 5, hello world, 5 through 9, and then 10. So, just a quick review. Statements are created by terminating an expression right here with a semicolon. All right, so that's a statement. That's a statement. This is all part of control flow. A block of code can just appear anywhere, and then it's got its own scoping. So this is when you declare a variable within a block created by the braces, then the scope of the declarations are within this block. Okay. Now, for branching statements, you've got the if-else, and the else clause is optional. So you can just have an if statement. You can have another if statement, right? They're not chained at that point. You can have if, else if, so that you could chain a bunch of these. I've only chained one, right? So if, else, you could have else if, else if, else if. But when you get to be too many else if statements, then you want to go to a switch if the type that you're trying, if the conditional expression that you're trying to evaluate supports it, right? In this case, the switch is a multi-way, right? So you can have multiple cases. Here I'm demonstrating case fall through, right? So this will fall through. To next case. Because it doesn't have a break, right? If you had a break statement in here, then it would exit out of that case, which is what this break is for. You have to remember, so as some of the newbie mistakes you'll make is when you write your first switches, you'll forget to put the break in a case, right? And sometimes that's easy to figure out that you've done that, and sometimes it's a little tricky that you figured out that you've made that mistake. All right, so save the code, and I'll run it one more time before we sign off, and this will conclude the control flow video. So GCC, and then clear the screen, and then run it one more time. And there we go. All right. I hope you enjoyed this video, and you'll see more control flow, branching, and block statements through the code throughout the course.